Hello everyone, and welcome back. In this video, I'll show you why I completely removed XML sitemap generation from my Angular frontend and moved it entirely into my Spring Boot backend. This small architectural change brings several important benefits. It simplifies deployments, reduces unnecessary dependencies, and ensures that Google can automatically discover newly published articles without requiring a new front-end build. Let's take a look at the original architecture, the problem it created, and why moving sitemap generation to the backend turned out to be the better solution. At the beginning, my architecture looked something like this. Contentful managed all of my content, the Spring Boot API provided the data, and Angular server-side rendering generated the website. At that time, Angular was responsible for two different tasks. It rendered the HTML pages, and it also generated the XML sitemap used by search engines like Google. Initially, this approach worked perfectly well. Every front-end deployment automatically created a new sitemap, and everything stayed in sync. But as the project continued to grow, I realized there was a significant drawback to this architecture. And that's what eventually led me to redesign the entire sitemap generation process. Now let's imagine I publish a new article in Contentful. What happens next? Contentful knows about the new article immediately. My Spring Boot API also knows about it right away. But what about the sitemap? The sitemap was generated during the last Angular build. That means it still doesn't include the new article. To update it, I would have to rebuild the entire frontend, create a new Docker image, upload it to the server, and deploy the application again. All of that, just so Google can discover a single new URL. To me, that felt like an unnecessary dependency between the frontend and something that really belongs in the backend. That's when I realized it was time to rethink the architecture. At that point, I asked myself a simple question. Which component actually has all the information needed to generate the sitemap? The answer wasn't Angular, it was the Spring Boot backend. The backend already knows everything it needs. It knows every published article, every available language version, the publication date, the last update date, the public URL, and whether an article is visible or restricted. In other words, all the information required to generate a complete and accurate XML sitemap already exists in the backend. Once I realized that, the solution became obvious. The sitemap didn't belong in the frontend anymore. It belonged exactly where the data already lived, in the Spring Boot backend. Today, the architecture looks much cleaner. Contentful still manages all of my content, but now the Spring Boot backend has two responsibilities. It provides the REST API and generates the XML sitemap. This means all SEO-related functionality is handled in one central place. The backend already knows every published article, every language version, and every public URL, so it can generate an up-to-date sitemap at any time. Angular is now focused on what it was originally designed to do, rendering the user interface. Nothing more. This separation of responsibilities makes the entire architecture cleaner, easier to maintain, and much more scalable. And from now on, every new article published in Contentful is automatically included in the sitemap, without rebuilding or redeploying the frontend. The implementation itself turned out to be surprisingly simple. I created a dedicated SitemapController, whose only responsibility is to expose the /sitemap.xml endpoint. The controller doesn't contain any business logic. Instead, it delegates everything to a dedicated service. That service does all the actual work. It retrieves every published article, generates the correct URLs, adds the appropriate refling entries for multilingual content, sets the last mod timestamp, and finally builds a valid XML sitemap. Keeping the controller this lightweight follows a clean architectural principle. Controllers should handle HTTP requests, while the business logic belongs in the service layer. This keeps the code easier to understand, easier to test, and much easier to maintain as the application continues to grow. One of the biggest advantages became obvious during deployment. To introduce the new architecture, I only had to deploy the Spring Boot backend. The Angular frontend remained completely unchanged. As soon as the deployment was finished, I verified the result with a simple curl request against the sitemap.xml endpoint. The new dynamic sitemap was available immediately. There was no need to rebuild the Angular application, no additional Docker image for the frontend, and no frontend deployment at all. Even better, the website remained fully available throughout the entire process. There was no downtime and no interruption for users. That's exactly the kind of separation I was aiming for. Changes to the sitemap can now be deployed independently of the frontend, making releases faster, simpler, and far less error-prone. Once the deployment was complete, the final step was to verify everything in Google Search Console. The new sitemap was detected almost immediately and processed successfully without any errors. From this point forward, the workflow became completely automatic. Whenever I publish a new article in Contentful, it's automatically included in the XML sitemap generated by the Spring Boot backend. There's no need to rebuild the Angular frontend, create a new Docker image, or perform another frontend deployment. Google can discover the new content during its next crawl, exactly as intended. That's how a modern, dynamic sitemap should work. The backend already has all the information, so it can generate an up-to-date sitemap at any time, while the frontend remains focused entirely on rendering the user interface. At first glance, this might seem like a relatively small architectural change. But in reality, it improves several aspects of the entire application at the same time. Responsibilities are now clearly separated. The Angular frontend is focused exclusively on rendering the user interface, while the Spring Boot backend is responsible for everything related to the XML sitemap and SEO. As a result, deployments become simpler, the front-end pipeline becomes leaner, maintenance is easier, and the overall architecture is much more scalable. Every newly published article is automatically included in the sitemap, allowing search engines to discover new content without any additional front-end deployment. To me, this is a great example of why clean software architecture matters. Not every responsibility belongs in the front-end. If the backend already owns the data, it should also provide the functionality built on top of that data. Making decisions like this keeps applications simpler, more maintainable, and easier to evolve over time. And in the long run, that's exactly what modern software engineering is all about. If you enjoy videos about software architecture, backend development, and real-world engineering decisions, consider subscribing to the channel. Here, I regularly share how I'm building my entire platform using Spring Boot, Angular, Docker, Jenkins, Contentful, and many other modern technologies. I don't just show the final result. I also share the challenges, the mistakes, the lessons learned, and the architectural decisions that shape the project along the way. If you're interested in clean architecture, DevOps, cloud-native development, and modern software engineering, you're in the right place. Thanks for watching, and I'll see you in the next video.